hydrocarbon derivatives.
The substitution of elements or group for one or more of the hydrogen atoms in a hydrocarbon results in the formation of many types of compounds which are referred to as derivatives of hydrocarbons. The derivatives of hydrocarbons may be classified into different types of compounds depending on the atom or group of atoms substituted for the hydrogen atom. There are 7 classified derivatives of hydrocarbons: ether, aldehyde, keton, amine, ester, carboxylic acid, and alcohol.
Hydrocarbon derivative. Alcohol. The hydroxyl group is very polar, making small alcohols miscible soluble in water. As the hydrocarbon chains become longer, the nonpolar property of the hydrocarbon starts to dominate, making larger alcohols less soluble in water. Since the hydroxyl group contains hydrocarbon atoms, hydrogen bonding exists, causing alcohols to have much higher boiling point than that the corresponding alkanes, or alkyls. ROH. Contain H bonded to O atom hydrogen bonding. Alcohols have higher BP than corresponding alkane. Like dissolves like, alcohols tend to be very soluble in water.
Aldehyde.
The slow oxidation of methyl alcohol yields formaldehyde, which is the simplest of the aldehyde. Formaldehyde ranks 22 in the top chemicals list, and it's prepared principally by oxidation of methanol using silver or iron molybdate catalyst under carefully controlled elevated temperature. A 40% solution of formaldehyde is marketed under the trade name of formalin, used as a preservative for museum specimens, as a disinfectant and insecticides, and in the preparation of synthetic resins. Used in the manufacture of such items as telephone transmitters and receivers, radio, equipment, comms, pencil, pep stem, and ashtrays. The general formula of aldehyde is R single bonded to C, C double bonded to H, and C single bonded to O.
Ether.
Pure ether, no hydrogen bonding. Weak dipole-dipole interactions. Bent like H2O. Ethyl ether once used as anesthesia. compared to alkanes, higher BPs than similar alkanes, more soluble in water than alkanes. Compared to alcohols, lower BPs than similar alcohols, much less soluble in water than alcohols. The general formula of ether is R single bonded to O, O single bonded to R.
The oxidation of isopropyl alcohol yields the metal keton, more commonly called acetone. Acetone, ranking using 48 in the list of top chemicals, is produced primarily by the above reaction using oxygen of the air and zinc oxide catalyst. The general formula of ketone is R is single bonded to C, C single bonded to R, and C is double bonded to O.
Carboxylic acid.
Organic compounds that contains a carboxylic group or COH group. Carboxylic acids can still be saturated hydrocarbons because the double bond is in between carbon to carbon atoms. Carboxylic acids are weak acids, which means they can donate hydrogen ions. The presence of both the C double bonded to O group and the carboxyl group very polar. The very polar carboxyl group makes carboxylic acid, which is with 10 carbon atoms or less, soluble in water. The carboxyl group also allows carboxyl group acid molecules to form hydrogen bonds with one another, causing the boiling points of carboxylic acids to be much higher than the corresponding hydrocarbons, which are alkanes, alkenes, or alkylanes, and even alcohols. The general formula of carboxylic acid is C double bonded to O and C is single bonded to OH.
Ester.
The general formula of ester is RCOOR, where the symbol R represents any hydrocarbon or just a hydrogen atom. The symbol R represents a hydrocarbon that cannot be a hydrogen atom. The C double bonded to O groups make esters somewhat polar, making ester with 4 or fewer carbons are soluble in water. Larger esters are not water soluble. The boiling point of esters is lower than corresponding alcohol or carboxylic acid because there is no hydrogen bonding due to the absence of the hydroxyl group. Ester usually have a smell or aroma, usually pleasant fruit odor. The general formula of ester is R single bonded to C, double bonded to O, single bonded to R, and single bonded to R.
Amine.
Amine may be considered derivatives of ammonia in which one or more of hydrogen atom of ammonia molecules have been replaced with an organic radical. As a matter of fact, these compounds are very similar in chemical properties to ammonia. The simpler amines are gaseous at ordinary temperatures and have an odor very much like ammonia. The general formula of amine is N single bonded to 3 Rs.